In this video I will show you how to solve some trigonometric equations. I will make use of the knowledge which you have learned on how to solve the trigonometric basic equations, and then I will also make use of some of the trigonometric relations which you have learned, and that is the ones which you can find in your note B. So how do we solve the trigonometric equations? Well, the two examples I have chosen to include in this video are the ones you can find here. The first equation is called 3 sine squared x plus 4 sine x minus 4 equals 0. And the other example, which I will solve afterwards, is sine 2x plus cosine x equals 0. So how do we solve the trigonometric equations? There are no precise guideline to go through when solving the trigonometric equations. You have to adjust to what equation you are faced with. So you have to look at the equation in question and see how can I solve this one. But there are two general things to consider, and that's the ones which I have noted here. The first one is that you have to make sure that all the trigonometric elements have the same argument. So up here in these examples you can see that in the second one we have both sine 2x and cosine x. So we need to do some rearrangements using our trigonometric relations so that we only have one same argument x. The second aspect you have to consider when solving the trigonometric equations is that you must make sure that only one of the trigonometric functions will show. That is, as you also see in this example up here, we have both sine and cosine, so we will use our trigonometric relations to make sure that we only have one of the trigonometric functions occurring, because then we can afterwards, by rearranging a bit on our equation, get to one of the trigonometric basic equations, either sine x equals a certain number, cosine x equals a certain number, or tangent x equals a certain number. And these three basic equations we know how to solve. So that's the aim. That's what we are looking for. We are looking for somehow rearranging our initial given equations into one of our basic equations by using the trigonometric relations. And when we have done that, we can afterwards solve these trigonometric basic equations as we have already learned. But let's try to take them one by one. We will start with the first example. The first example I have chosen to include is the 3 sine squared x plus 4 sine x minus 4 equals 0. As we can see, we have only sine included here, so we have no restrictions to x. X belongs to all our real numbers. So how do we solve this equation? Well, this one here is actually quite straightforward if we are able to see that what we have here is really a masked quadratic equation. Because if I substitute y to be equal to sine x, what will then happen? Let's try. I say I substitute y to be equal to sine x, so what do I have? I must have 3y squared plus 4y minus 4 equals 0. And that's okay if I say that if I at the same time state that y is equal to sine x. So let's try to look at this. If y is equal to sine x, then 3y squared must be the same as 3 sine squared x, plus 4y must be the same as plus 4 times sine x, minus 4 equals 0. Alright. So what do we have here? Well, we have a quadratic equation which we can solve for y, and that gives me two solutions. Y is either equal to 2 over 3 or y is equal to minus 2. But we are not in the beginning here, we are asked to solve this equation for x. So we need to substitute back again and say if y is equal to sine x and y in the same time is equal to 2 over 3 or minus 2, then I can say that sine x must be equal to 2 over 3 or sine x must be equal to minus 2. And now you see I have, based on all these operations I've did here, I have reached down to two trigonometric basic equations which I know how to solve. So we solve them side by side. We'll take the first one. Sine x equals 2 over 3. So x must be equal to inverse sine 2 over 3, that is 0.73 approximately, plus p times 2 pi, or the second potential solution will be x equals to pi minus 0.73, which is 2.41 plus p times 2 pi. So that's the two potential solutions I have from here. So let's look into the other potential solution to our equation sine x equals minus 2. Does that give me any solutions? No, it doesn't. Because recall from when we talked about sine x equals a, the trigonometric basic equation sine x equals a, that leads to a restriction to a being in between minus 1 and 1. Otherwise we will not have any solutions to our equation. So sine x equals minus 2 will not give me any solutions to x. If you have any questions to that, then look into the video called Sine x equals a for further explanations. So we actually only have two solutions to the initially given equation here, and that is x has to be either equal to 0.73 plus our period p times 2 pi, or x is equal to 2.41 plus p times 2 pi, and of course p has to be an integer. So that is one way of solving trigonometric equations, and that's a method which you will often see, that if you are able to somehow rearrange so it will be a mass quadratic equation which you can solve, then that's one of the methods where you can solve some trigonometric equations. Alright, that was the first example. The second example I have chosen to include is sine 2x plus cosine x equals 0. And as we can see, we have sine and cosine included, so no restrictions to x. X belongs to all our real numbers. Here we have the problem with the argument, but no problem, because remember from the trigonometric relations, which you can find further information about in your notes B, sine 2x is equal to 2 times sine x times cosine x. And then I of course have to add the cosine x, that is equal to 0 according to the initial given equation. So now you can see, based on this small operation, I have only one type of argument x. So that's perfect. As we in the first example saw that we could solve that one by looking into the mass quadratic equation, in this example you see another method which you will also often see is a possible solution method to your trigonometric equations. Because if the equation is equal to 0 and you have the same element included in both here, this section and that section, what we can use is the zero rule. Remember that if the zero rule says that if you multiply two numbers being equal to 0, then either the first number or the second number must be equal to 0. That's the knowledge which we use here. If we move the cosine x, which is both part in this section and that section, outside the bracket, what will we have in the bracket? Well, what do I have left in that section? That is 2 sine x plus 1 equals 0. You see, if I expand this bracket, then I get 2 times sine x times cosine x, that's what I have here, plus cosine x times 1, that cosine x equals 0. And then I use the 0 rule that either must cosine x being equal to 0 or 2 times sine x plus 1 be equal to 0. Otherwise, if that's not the case, the product between these two will never be 0. So already here I have the basic equation, and over here I can just rearrange a bit, and then I have reached the basic equation which I can solve. So we could start with the first one over here. Cosine x equals 0, then x must be equal to plus minus inverse cosine 0, which is pi over 2, plus p times 2 pi. So that's the first solution which we have. Or, and then I just rearrange and isolate sine x. That must be sine x equals to minus 1 over 2. I subtract the 1 on both sides and divide with 2. And then I have the trigonometric basic equation sine x equals minus 1 over 2, which I can solve. So x must be equal to inverse sine minus 1 over 2, which is minus pi over 6 plus p times 2 pi, or x equals pi minus pi over 6, which is 7 pi over 6 plus p times 2 pi, and for both solutions p of course has to be an integer. So we end up with 4 solutions to the initial given equation, plus or minus pi over 2, minus pi over 6, and 7 pi over 6. So how we solve trigonometric equations? That is very individual and based on the equation you are given. So you have to look at the equation and see for what operations can I make sure that we only have the same argument all over, and which operations can I use to make sure that only one of the trigonometric functions occur, so I can get down to one of the trigonometric basic equations which I can solve. If you have any questions to the trigonometric basic equations, look into the videos cosine x equals a, sine x equals a, or tangent x equals a. Thank you for now.